Okay, thank you so much, everybody, for having me. It's a pleasure to be here with you. I love to talk to my friends here in South Florida. I think I know some of you here in the call, including Fernando and Cecilia, but my name is Eumar Assis. I'm a partner technology strategist here at Microsoft, and essentially I work with ISVs, independent software vendors, and software as a service providers to build new solutions on the Microsoft platform. My end goal, if you're familiar with the Microsoft Azure Marketplace and App Source, what we call the commercial marketplace, my end goal is to build new solutions that enrich that marketplace. As you can notice from my accent, I am not originally from the US. I actually started my career in Brazil 17 years ago and moved here to the US 6 years ago as Microsoft transferred me from Brazil to Latam. So this is what I do here at Microsoft. I work in our organization named Microsoft One Commercial Partner, and we work with partners like Cecilia, helping them envision new solutions, go to market, and co-sell with Microsoft. And I sit here under technical. So what I prepared for today, actually I presented this deck 2 years ago, and I've been using the same deck since then because I try to organize this message to not be so subjective, not to be, if we change the technology, let's say if we added a new Azure service, I wanted to keep the same agenda, but I have to be honest, I have to adapt this to some of the changes Microsoft has made recently, but I think we can still walk you through the agenda I have here. But I think this is the 5th time I'm delivering this presentation, and normally the feedback is very well. So what is my agenda here? First, let's start with the basics. I just want to review what is artificial intelligence and machine learning. I know that every company, especially companies who are looking for investors, they love to use the word AI, but what is it AI? I see a lot of companies just doing some group buys in the database, just doing some if statements, and they claim that they are AI companies. So let's demystify that and make sure that everybody understands what is AI and what is the difference between AI and machine learning. As you hear me saying, great powers will bring great responsibility. So I want to talk about AI ethics and fairness. And then from there, we can really talk about Azure. How can you leverage Microsoft Azure to build new AI solutions? But what I would like you to understand is the landscape, the AI landscape. You can use AI solutions that are already ready for you. For example, Cortana or Power BI Q&A. These solutions are ready for you. You can just use them or embed them in your application. You can also start including some of the Azure Cognitive Services, some Azure capabilities, AI capabilities into your application. Then if you really believe that you have a special use case, you have a use case that Microsoft doesn't have a built-in API to support your needs, then you can build a machine learning model from scratch to build that AI capability. And finally, what I wanted you to know is that Microsoft has a catalog of AI solutions that you can leverage. So really, my goal for you today, after this 1 hour, probably now after 50 minutes, is for you to understand the Azure AI landscape. You understand which solutions are already ready for you to use, which APIs you can include in your application, and if Microsoft doesn't have what you're looking for, you can create solutions from scratch. And to do that, I will talk mainly about Azure Cognitive Services and the Azure Machine Learning Solutions. Basically, we have Azure Machine Learning Service and Databricks. Lastly, I believe after you seeing this presentation, you will be able to understand when to use what. Cool. So I like to start with the basics, as I mentioned. So this is just the formal definition. So AI, artificial intelligence, is any computing program, is any algorithm that mimics human behavior. Okay, that's very important. Then we have a subset of AI, which is machine learning, which is a method for you to use mathematics and statistics and leverage historical data to build capabilities that mimics human behavior. But a key aspect here is that you can be using machine learning models for building capabilities that does not mimic human behavior 100%. For example, if you're predicting that a customer will churn, one can claim that a human cannot predict that a customer will churn, that a customer will stop buying my product. So machine learning is really a subset of AI, but the key here is that with machine learning, you're using historical data, combining statistics and mathematical modules to improve experiences. Then deep learning is a subset of machine learning. It has become very popular in the last 10 years. And this is a capability is basically allowing you to build deep neural network. And the reason it has become very, very, very popular in the last 10 years is because of GPUs. For you to build a deep neural network, you need a lot of computing power. You need to do a lot of mathematical computation. And with GPU, you have that. Okay, so these are kind of the formal definition. But really, the reason why AI has become the norm, and it's not just because companies, and I've realized, okay, cool. And the technology breakthroughs that are enabling AI is not just GPU. As I mentioned, machine learning is the capability for you to analyze your data, historical data, to infer new decisions. We've always had machine learning models. If you see my previous slide, logistic regression, linear regression modules, they have been out there for 30 years. But the reason why the AI has become so prevalent these days is because we now have a lot of data, especially because of the amount of data we are leveraging, we are collecting, we're ingesting from social media, from IoT devices. So we can leverage these powerful algorithms. Yes, we have evolved these powerful algorithms, but with machine learning, with AI, the more data you have, the more quality data you have, the better the answers you will have. And then you have cloud, you have Azure, you have Amazon, you have GCP, you have the cloud computing that can harness, can process all this big data. So the combination, this trifecta of big data, powerful algorithms, and cloud computing is what has made AI to become a reality. And is also the reason why companies love to use the word AI. Perhaps they believe they are going to raise more money, but a lot of companies are using AI for real. I am focused this year in retail companies, and I would say 80% of the companies I'm working, we have some component that involves AI. And for the last 3 years, I was doing healthcare. In healthcare, all my projects, they involved IoT and machine learning. So I can see on the projects that I'm working, is not people just asking me, oh, Eumar, how can I do this with cognitive services? Because I have a customer that might use that in the future. No, I'm working in real projects. All my projects, there is some component of AI or machine learning involved. So this is no longer when this could happen in the future, this is a reality. An important aspect here is also about Microsoft's credibility. Normally, people, when they think about AI, when they think about machine learning, the first company that comes to their minds is IBM Watson. And then Google, because people just like Google. I don't know why, but people just like Google. They think that everything that comes out of Google is awesome. And I believe with some technologies are awesome, including TensorFlow, which is one of the key technologies for deep learning that Google has invented and has made deep learning very accessible. But you can see here, these are some of the breakthroughs that Microsoft Research, MSR, has made over the last 10 years. So essentially, we are reaching human parity, and we are human object detection, computer vision parity with humans. So you can see that AI is mimicking human behaviors, and we are reaching parity. The accuracy that our machine learning models have today are very similar to a person's. And you can see here again, this slide is to prove the point that Microsoft invests a lot in research. And in our research team, we have had a lot of success and breakthroughs building computer vision. My question to you all, and normally when I ask this question, I have a sticker or some gift to give away. But whoever gets the first answer here is going to get a gift that I will send to you later. So the question is what is the company with the most AI patents right now? What is the #1 company that has patents related to AI?
Microsoft.
Okay, who is the second?
Amazon.
Okay, why Microsoft is the #1? Why do you believe Microsoft is the #1 if IBM and Google they have mindshare?
Because when you look at the amount of money that's being spent by Microsoft development on an annual basis and the amount of stuff that they're doing in the Azure environment, it's pretty obvious. And I think I read it somewhere, but I don't remember where.
Cool. Oh. Fair answer. So yes, it is Microsoft. IBM is actually the second, and this data is based on Statista. And I don't know the gentleman, his name, the person who made the comment. This is not something that happened overnight. This didn't happen just because Microsoft is investing on Azure. If you think about Word, Outlook, all the cloud applications Microsoft had, the amount of AI that is embedded that we don't even think about, like suggesting the next word you're going to type on Word, translation, there are a lot of AI embedded in the Office platform on Microsoft Cloud Services. But what we have been doing recently is investing resources to make sure that those AI capabilities are available to you as API. So that's why we have a lot of patents, okay? So people might think that Google is cool and IBM is awesome, but data, this is a session about data, right? So data says something different. Cool. Again, these are customers, real customers who are leveraging machine learning, AI, Azure AI. I like the story of Starbucks because they use Azure Sphere. They have an Azure IoT platform, and they use machine learning to do predictive maintenance of the coffee makers in every location. So Starbucks, I love that story, but you can see here we have customers leveraging Azure machine learning capabilities in different industries, including healthcare. However, we all know, I think everybody has watched this movie, with great power comes great responsibility. And what I mean by responsibility are some of the news, the headlines that we have seen in recent years. And the one that really made me think about machine learning and think about the society we live in is that the US criminal system had built a machine learning model that was biased in the wrong way against Black Americans. And this is not a session to discuss systemic issues we have in our society, okay? Happy to discuss that over a coffee discussion. But this is just a fact of a solution that was built by the US criminal system that was racist towards Blacks. Why is that? I started the session mentioning machine learning leverages mathematical models and statistics to identify patterns you have in the data. So if in your database, 80%, if you're in your criminal justice database, 95% of the criminals that were loaded into the database was from a specific race, for sure, the output, the prediction is going to be racist. And I also like scenario here is this Amazon's AI model that was racist, that was biased against women. And I use this to highlight one point. This is why it's so important to have the right representation in our IT projects, especially from women and minorities. Because why? In this case of the Amazon's algorithm, if you have 10 males building the algorithm, and probably they are inputting some of the data that they created on their own or their own information, of course, the machine learning model is going to be biased towards men and therefore against women. So we have a responsibility. It's not just about populating our databases, our master data model, and building models on that. We need to make sure, especially when we are building capabilities that impact people's life, we got to make sure that the data represents the society and we are not building the wrong bias into our data. Okay? If you don't want to learn anything else out of this session, please remember this slide. So we, Microsoft, we believe that before I can teach you about Azure Machine Learning Service, Azure Cognitive Services, you should embody on your solutions when you start using Azure AI, fairness, reliability and safety, privacy and security. You want to make sure that your solutions are inclusive, they are transparent, and they are accountable. And I like a lot the transparency because this is an area where the academia is researching a lot. So for example, if I have built a machine learning model that predicts if Fernando is going to default on his loan, on his mortgage, how can I give Fernando clarity on the factors that are used in this machine learning model? So historically, machine learning models, they have been like black boxes. You just throw information out there, you train the model, then you use that model to predict something and you give a score. But companies are being forced to give visibility, give clarity on how these models are developed and how certain decisions are made. Okay, so if you're looking for a topic to do your PhD thesis, or if you're bored and you want to study something, I highly recommend you check about AI ethics and how can you drive transparency about your machine learning models. This last build, Microsoft build, there were several sessions about this topic. And here's just another quote from our president, Brad Smith, about the responsibilities of computers. And that is enough. Okay, so in terms of Azure AI Landscape, there are applications that you can use like Cortana and Power BI Q&A. Then we have pre-built machine learning models that you can just embed on your application by calling APIs. And this is what we call cognitive services, the bot framework, and knowledge mining. And this here, the last one, now we call this, because I mentioned this slide is a little bit old, we call that cognitive search. Okay, so on the section include AI, these are APIs that you can just call using a REST endpoint that you can include on your application. And they are divided in cognitive services, bot framework, and knowledge mining. The name of the solution on Azure is Cognitive Search. Then if you are not happy with these pre-built Microsoft algorithms, you can build AI solutions. You can build machine learning models from scratch. When it's time for you to build your solution from scratch, you have to choose between two key solutions today. Either you're going to go the Azure Machine Learning Service route, which is a first-party service managed by Microsoft, or you can leverage Databricks, which is basically doing machine learning with Spark. And again, both of these scenarios, we have a managed service on Azure, but Databricks we require that you have experience working with Spark ML, while Azure Machine Learning Service is a first party by Microsoft, so you just need to learn that service. Then the last one, just want to highlight, and you see in the end, there is a AI solutions gallery that you can find some pre-built models, you can find some sample code, so I recommend you check that out. So in terms of using AI, Cortana is one of them. Like you can just ask Cortana. Everybody's familiar with that. Another one is, I don't know if you're familiar, but with Power BI, you have this Q&A capability. And basically, you can add the Power BI report into your application using what we call Power BI embedded. I don't have this demo today. I normally do this demo, but my environment got messed up. But what I wanted you to know is Power BI already has like a Cortana embedded within your reports that you can ask questions about. You see, I just said her name. And sorry, I lost the focus here. I said her name and she just popped up. So the point here is with the Q&A capability you have on Power BI, you can ask questions about your data, about your data sets, about your reports, your dashboards. And essentially, you're giving non-technical users, non-super users, the ability to query the data on a very simple manner. But the most important point here that not many companies are leveraging is you can just embed a Power BI report into your cloud, into your custom applications. Let's say you have a web application that is used on the intranet, that is used by external customers. You have a software as a service application, and you don't want to build your custom reports. You could embed reports into your application, and you can allow that capability for Q&A. When I show you the dashboard I built for the cognitive search, I'll try to show that capability on Power BI desktop. So changing gears now, I mentioned these were the two examples of using AI. Now I'll talk about including AI. So to include AI in your application, we have cognitive services. These are APIs that mimics human behavior. We have APIs around vision, speech, language, knowledge, search, and these are labs, technologies that Microsoft Research are investing on. And actually, I said new, this is no longer new because this slide I updated last year, but we have added additional capabilities in terms of our cognitive service. For example, we have the decision, which this comes with the personalizer. This is like recommending certain products, certain features using deep reinforcement learning. This is, for example, how Xbox on your home screen will always show the games that you prefer most. We have also released cognitive services around anomaly detection. We have improved our language capabilities like support for Brazilian Portuguese recently. Vision, we have ink recognizer, computer vision, speech, web search. And one thing that I don't have here, and that's what I was trying to add on the slide, is we have recently launched the forms recognizer. This is the ability for you to do OCR in documents and extract that as plain text. And it's very cool. Like I'm working with a retail company who is analyzing sales receipt. So they can see how much customers are buying, etc. They can do loyalty programs. So Forms Recognizer has been one of the latest services we've added and a lot of customers are using. Okay. These are some of the capabilities you have under each service. So for Vision, you can use the video indexer. So for example, if you are using the Azure Media Services to encode your videos, you can actually use the video indexer to transcribe what is being said on the videos, to do sentiment analysis. We have computer vision, face detection, emotion detection, Content moderator, this is especially important. For example, if you have a forum and you want to restrict what type of content people are talking about. And the key of this slide here is that for every cognitive service that we have today, we are allowing you to customize that. And another aspect that I didn't mention is all these services now, we are allowing you to deploy them as a Docker container. Why is this important? If I want to do, for example, a face detection, and let's say I want to use a face detection algorithm to decide who enters in my house or not. For me to send that to the cloud might take a while. So what I could do, I could just deploy the computer vision as a Docker container on a local device in my machine, and that would do the work. If you have seen this presentation before, I think what is new to you is a lot of these services can now be available as a Docker container, so you can run that on premises. You can deploy that, for example, as a Azure IoT Edge module. The other category of built-in algorithms we have is what we call knowledge mining. In terms of Azure service now, this is called Azure Cognitive Service. Sorry, Azure Cognitive Search. And this is the ability for you to extract from unstructured documents key information. Is the ability for you to do OCR. So in this scenario, you could have unstructured documents, and you can leverage Azure Cognitive Search to extract key phrases, to extract common faces, organizations that are mentioned, locations, people, sentiment, language detection, tags, and so on and so forth. And then once you are able to extract these components from those unstructured documents, you can make them as structured information within your index. And in that case, your index could be a Azure search. These are some scenarios on how you can combine these Azure Cognitive Services to build real-world applications. For example, leveraging face detection, computer vision. You have a Seeing AI to help blind people, and I'll show you an example. You can leverage cognitive services to do speech-to-text, text-to-speech scenarios, language detection. You can do bots, you can build bots leveraging the Q&A, and that's it. So I wanted to show you a quick demo, and of course, leveraging those cognitive services are the key component for you if you're going to build a bot. A bot is basically a web service that can process what users type. Let me take a step back. So if you were to build a bot today, you would leverage what we call the Azure Bot Service. But Azure Bot Service is just a web service that receives a certain question from the user. But normally, when you receive what the user has typed on the bot, you need to identify the language. You need to understand what the user is actually asking. Perhaps if your bot understands your FAQ, it will want to redirect the users to FAQ. So normally, you want to build a bot that is helpful, meaningful for customers, unless you are integrating all these cognitive services into your bot. So just make sure you understand this. Azure Bot Framework is one thing. It's how you host the backend for what users type on the bot window. The intelligence, the skills that your bot will have will come from Azure Cognitive Service. Okay, so I wanted to show you a couple of demos. I had mentioned that for the user that we have some cool apps, and I'm pretty sure that not many of you knows that we have what we call the Cortana calendar. This is a very cool feature that will help you schedule meetings. So I work with people outside Microsoft and within my team all the time, and it's very hard for me to understand when is everybody going to be available. So when I'm scheduling a meeting, I just email Cortana. I copy the people who I want to be the meeting, and Cortana will schedule the meeting on my behalf. So here is an example. You can just email Cortana and the people you want to invite. You tell Cortana, find the time for me to meet with this person. And because Cortana understands natural query language, she will be able, and even if you say like, schedule a meeting with Michael and Ricardo this week for a kickoff, this week or next week in a Teams call, Cortana can do that, can schedule a meeting and add a Teams meeting or book a room. Based on your availability and based on if you have access to the calendars of the people you are inviting, Cortana will automatically schedule the meeting based on everybody's availability. So I know that not many people are familiar with this capability, but this is just an example on how you can just use a AI capability, AI solution that is already built by Microsoft, and you can just start leveraging that today. So if you have trouble like me to find what is everybody's availability, just start leveraging Cortana to schedule your meetings. I'll paste the link here on the chat window. This is a private preview, so I can't guarantee that you will be approved, but I recommend you give it a try. And somebody asked the question, what is the difference between a virtual agent and Azure bot? It's the same thing, okay? Azure bot, we don't have a service called Azure bot. We have a service called Azure bot service with the Azure bot framework. And that gives you all the tools, all the plumbing to build the back end of your bot. But companies will refer to bots as virtual agents. So a virtual agent, a bot is the same thing. But in terms of Azure service, we have a service called Azure Bot Service that helps you build your backend. Okay? So I hope this has been helpful, the Cortana Calendar Assistant. I know that not many people use this. This is not available to everybody. Give it a try if you get accepted. But if not, you'll be one of the first ones to have access when this is available. So this is one scenario. The other scenario that I wanted to show you, if my Power BI desktop allows me, in the meantime, if you have questions, feel free to type them. Okay, so while I wait for that one, I don't know how many of you are familiar with this demo, with this website, but this is a demo solution Microsoft that was able to analyze all the unstructured documents, all the PDFs from the JFK assassination investigation, okay? So what Microsoft was able to do, we uploaded all the PDFs with the written notes, all the documents that the US government made available about JFK's assassination. We applied the Azure Cognitive Search to analyze this unstructured data, and we have the solution you have in front of you. So I'm just going to search for Oswald. And you can see here, when I search by Oswald, you can actually see within the documents the words I'm looking for. And what I like most about this is even if these are handwritten notes within the documents, Azure Search can find those. So let me just make this available here. here you see somebody wrote on a very bad handwritten like mine, Oswald, and Azure Cognitive Search was able to find that within the document. So how did this happen? Again, Microsoft applied the Azure Cognitive Search to these documents. Azure Cognitive Search used the Azure Computer Vision Cognitive Search to analyze the data within this document. And look what is cool here. It extracted some tags from within the documents, like CIA, the times it is mentioned. And what I like about this solution is, if you want to understand how this is built, it's available to you, is a reference architecture, and you can actually find the sample code for this solution on GitHub. So I'll paste the link here on the chat window. But like I mentioned, what we did, we uploaded all the unstructured data into Azure Blob Storage, all the images. We applied the cognitive search. We applied OCR, computer vision. We created that index in Azure Search, and then from there, we can analyze that data. Let me just show you on the Azure portal how you would do that. I won't do the demo end to end, but I wanted you to understand. So what you can do here on Azure, you can create the service called Cognitive Search. If my internet helps, okay. So you'll find here Azure Cognitive Search. You can just follow the basic steps, which resource group you want to deploy this to, which region you want to use this. For Azure Cognitive Search, you pay based on the number of partitions and indexes you have available. And this is essentially how you're going to scale your solution. So you pay per use. I have already gone and created a Azure Cognitive Search. But in here, if we go back, and we go into this Azure. In here is where you can connect which data you want to process with Cognitive Search and which Azure Cognitive Services you want to apply when you are creating the index of your data. So for example, in here, I can select samples. I'm just using this real estate for now. And here is the key aspect I want you to know. Here is where you can attach a cognitive service to your, and I should refresh, but that is okay. And in here is where you can say, I already defined where my data was. In here is where I associate the Azure Cognitive Service. I want it to be attached with this. This is more for billing, so you understand, because you'll be billed by different components. You'll be billed by the Azure Cognitive Search, which is just indexing your data, but based on which enrichment you want to do, that will be a call to your API. So in here, for example, I'm saying, okay, I'm going to index all the data that is on my blob storage, and I want to be able to extract the people's name, the organization's name, the location, key phrases, language, etc. So what I had done on the demo when I delivered this presentation the last time, I selected all these options, and I said, I want to save these enrichments to a Azure table, okay? So I saved all those enrichments to an Azure table, and I built, if my Power BI opens, Power BI desktop opens, any questions so far while we wait for Power BI to open? Yes, I know I need to update Power BI. I'm not working with Power BI very often recently. Okay. So what I had done, I had created an index similar to how Microsoft did to JFK, in this sample. I uploaded some PDF documents from the investigation into my Azure storage account. I imported that data. I created the enrichments, and I saved the projections to an Azure table. And what I did here, I built a word cloud with the locations, the organizations, the people, and key phrases that were contained in the PDF documents. So this is a very practical example of extracting unstructured data, indexing that unstructured data, and leveraging the cognitive services, the AI capability that is available there to transform that unstructured data into structured data on a table. And then I was able to build this very cool visualization, so we understand what were the key aspects, the key words that were being discussed in the investigation. This is what I wanted to show in terms of the JSK investigation. That's another capability I had mentioned to you, the ask a question. This is just the Q&A capability. And where did I put that? So if I say organizations count, I don't know if this is gonna work, but let's try, because I need to count organizations or count people. Yeah, 2 people in there. This doesn't seem right because I'm not connected, but that's good. You get the idea. Without spending any time, I can just ask questions about my data. So if I look here within the entities, let me see. Location. Yeah, this is better. This is better. So you can see here that leveraging the Power BI native Q&A capability, I can just ask questions about the data. I know that the size here is not good, so let's just create a new report here. And I would just say organizations as table. No, let's ask for key phrases. Yeah. You get the idea, right? So I can very easily leverage Powers BI AI capabilities to answer questions about my data, and I could easily embed this dashboard into my application. I also wanted to show you another cool application that is going to be fun. All the demos I'm showing to you, I have the links for the source code. I will share everything, anything I'm presenting here, you have access. So I am gonna open this application that is built on C#. And basically what it does face detection, and it does sentiment analysis on the live camera. And I will have to stop my video from Teams just for a second. And what you're gonna see now is I'm starting my camera. Hi there. And it's actually able to predict my age. And if, for example, I wanted to see my emotions, happiness. Yeah. And for example, if I wanted this to describe what I have in front of me, so it can describe that it's a person that is indoor, there is a bottle, a soft drink, clothing. So this is the technology we used on the Scene AI, and just an example of using cognitive services to extract tags from images. This is one, and I have the same sample here, but in Python code. Just an example in with how many lines of code. If we discount the imports here, with 3 lines of code, I can print all the tags from this image. So let's do that very quickly. So I'm just informing this image, and I will leverage the computer vision cognitive service, and I will extract all the tags from this image. So let's do that. And you're seeing here, analyze image. It's the tags it has returned to me is skyscraper, building, outdoor light, everything we have here. So let's look for another one. This one, we are using the cognitive service to look for forget about this error. The important one here, let me stop here. Just a second. So I would like to stop here because my goal is to show you a landmark. Okay, I want to stop. So leveraging cognitive services, we want to analyze this image, and I will leverage the landmark API. So just call captions. So I'm just calling analyze image by domain. The first one is the first image we had. So in here, celebrities, did I add? Oh yeah, I think I had an image of a celebrity. No, not on this one. Okay, and here is the scenario I mentioned. So describe image on captions. I was able to extract here that this is an image from the Golden Gate Bridge in California, and this is the level of confidence that the API has. So just some examples of leveraging cognitive services, leveraging computer vision to build real-world applications. I'll send the samples to you. You have that in Python and in C#. And yeah, so let's switch topics now. So what we saw so far is leveraging cognitive services, combining cognitive services with Azure Search to do what we call cognitive search, which is now the name of the service is Azure Cognitive Search. We also saw some samples leveraging C# or Python, and I also demoed to you 2 applications that have AI applications, including the Cortana calendar scheduler, as well as the Q&A capability in Power BI. So let's say you have taken a look in the Azure AI capabilities and you identify that the APIs we have available does not provide what you're looking for. And you've realized that you need to build something from scratch. So there are several tools and the infrastructure that Microsoft makes available to you for you to create AI solutions. So examples of solutions of machine learning models that you normally need to build your own model, or you have to start from a sample from the AI gallery. Let's say you want to predict how much a car is worth. So normally the way you do that, you have historical data with the price of car sales in the past 12 months, and based on the model, based on the year, you can predict how much a car is worth. Same thing if you want to predict how much a tax fare is going to be. So you load all the historical data from the tax rights from recent database, and you can predict that. So then let's say you want to predict if a patient, the probability that a patient will have a certain disease. So that is another scenario where you need to build your machine learning model from scratch. And in this scenario is what we call a classification scenario. Same thing for sales forecasting and other scenarios that involve deep learning, like computer vision and autonomous vehicles. This is just a terminology review. I'm not going to spend a lot of time here, but the basic concept of a machine learning model is you get your historical data and you plot that on a map of all the records you have. So let me just go slow here. Okay, so the idea of building a machine learning model is that you can get all of your historical data and you can plot that data on a graph, right? We have like here. And you want to build this line that passes closest to all of your occurrences. So in this scenario that we have the observations, we have a database with the investments that were made in advertisement in TV, radio, and newspaper, and the outcome in sales that we had based on advertisement. If I wanted to predict how much I should invest in each of these channels to get a certain amount in sales, and let's say I wanted to predict how much sales I would drive if I invested $175 in TV. So what basically we can do here is, because this line passes close to all my occurrences, I could just find the point that is right here, which is closest to $175. And I can go to the left and I would see that this would yield probably around 14,000 in sales. This is a very, very, very basic definition of a machine learning model. In this case, we are leveraging a linear regression model, okay, because we want to predict a specific value. And that's a model in very basic terms. Now, probably, what if you wanted to see the combinations of investing in all these resources, or if you had more variables you wanted to predict, things will start to get more complicated. But that's the basic, and in this was a linear regression model. Then in this scenario here, we have a logistic regression model, which this is a type of classification scenario where I want to understand if a patient will have cancer or not. So I want to identify either the patient is here or here. This is a classification. And logistic regression is another type of model that can also be used for classification scenario. So this is an example of a model that predicts how much I should invest in advertisement to have a specific amount of sales, while this one here can identify if a patient falls within a specific category, if a patient has the probability to have a certain disease. This is a model. Now, you cannot build machine learning models without the right data, without the right people. So you need data science, which is a approach for you to have a multidisciplinary team combining people that have data engineering, data analysis, and domain expertise. So if I want to build a machine learning model that is going to predict the prices of cars, first I need to make sure I have data engineers that can build a database with the prices of all car sales in the past. So that's where we need data engineers. People who know a little bit of programming and who know a lot of data tools, who knows, especially Python has become very popular for doing data engineering. Then you need somebody with domain expertise. If you are building a solution to predict car sales, you probably will want to have somebody who has experience, maybe perhaps a dealer owner, and so on and so forth. If you are building a machine learning model for healthcare, you probably need somebody in healthcare. Then you actually need somebody with math and statistics knowledge. The models that I mentioned here That's where you need to understand mathematics, even though a lot of these models today come to you as APIs, are easy to use. Somebody with mathematical and statistics expertise that can do exploratory data analysis will be very important. So data science is this idea of combining people with these three different skill sets to be able to build machine learning solutions. Microsoft has what we call the data science process, how you can combine these resources and how you can define this. The good news is that with the Azure Machine Learning Service, we have tried to embed this data science process as part of the tool. So if you are leveraging the Azure Machine Learning Service, which is a first-party service on Azure for you to do end-to-end machine learning. But if you have expertise on Azure on Databricks with Spark, you can also leverage that. Or if you're using other tools like you're using other frameworks like TensorFlow for deep learning, you can just leverage the Azure Virtual Machine Data Science Virtual Machine that already comes with all these resources installed. And I forgot to mention that Azure does support most of the frameworks we have in market today, especially for deep learning. TensorFlow and Keras are the two main deep learning frameworks out there, and we do support that. And of course, we have VMs on Azure that are based on CPU, GPU, FPGA to support the different machine learning workloads. For you who have had some experience working with these services, Azure Machine Learning Workbench, Azure Auto ML, Azure Batch AI, Azure Service Visual Interface, Azure Machine Learning Service Visual Interface, they have now all been combined into a single service. We have made enhancements, and we now call them Azure Machine Learning Service. Azure Machine Learning Studio is still out there, but we encourage you to focus more on Azure Machine Learning Service. We also have the data science virtual machine, and we have the tools for the AI tools for Visual Studio Code. This is what I was mentioning, how you can leverage, you can integrate Azure Machine Learning Service to have end-to-end management manage the life cycle of your models end-to-end, so you can train your models on Azure Machine Learning Service, and you can containerize your models as a Docker container. Then you can deploy your models anywhere, and you can orchestrate out this process with Azure DevOps. This is just the demos of how you can build a auto machine learning model on Azure. Basically, in this scenario, let's say you wanted to predict how much is this car worth. Assuming you already have the data, the questions you would have to ask is, which features, which columns am I going to use to predict how much is this car worth? Then I also need to understand what type of algorithm, machine learning algorithm, I am going to use. Am I going to use a nearest neighbor model? Am I going to use logistic regression? Am I going to use gradient boosted? There are many algorithms out there, and each of these algorithms will have parameters. So what we allow you with AutoML is kind of do a combination, is to try out all these features, all these algorithms and these parameters, and give you a recommendation on what would be the best model to predict that scenario. So this is very cool. And we're giving here the example, let's say first Azure Machine Learning AutoML would select these three features. Would we use the gradient boosted algorithm, would select these parameters, and the model would have 30% of accuracy in the prediction. Then we changed to the nearest neighbor and we got this accuracy, and so on and so forth. And then we finally found the algorithm that gave us 95% of prediction. So all of this is provided by default out of the box by leveraging the Azure Machine Learning Auto ML capability. I'm not going to spend a lot of time on this because I have the recording on YouTube if you are interested. And here is just the output of the Auto ML results, it actually tells you which features have more relevance in the prediction. And it will also give you some suggestions, explanation on the modules, the best modules to be using. Again, this is just more details on how you can have end-to-end management, lifecycle management of your machine learning solution. This is some of the capabilities we have now with Azure DevOps. So Azure DevOps is integrated with Azure Machine Learning Service. So you can run AutoML jobs, you can provision model validation. A lot of the capabilities you can do through the UI, you can do with Azure DevOps. And here is the key recommendation for you is when to use what. So if you are a Python machine learning developer, you can use Azure Machine Learning Service end-to-end to do the data preparation, build and train your modules, manage and deploy your algorithms. If you are a Spark developer, you can leverage Databricks, and you can combine that with Azure Machine Learning Service to train and deploy your modules. I was going to do an overview. So let me, because we are out of time, let me just explain the part. Just wanted to let you know that we do have this AI solution gallery where you can find other solutions like the ones I did the demo to you today. So highly recommend you go there. Just go to gallery.azure.ai. And here's just a recap of what I mentioned, the difference, what I covered today. I basically covered the difference between AI, machine learning, and deep learning, the importance of AI ethics, the difference on the Azure AI landscape, including creating and finding AI solutions. And on the last slide, I explained the difference between Azure Machine Learning Service and Databricks and when to use one versus the other. Here are the key resources I recommend you check. All the demos I covered today, the links are available here in the presentation. I will share the presentation with you. And if you want to watch more demos, more videos on of the Build conference for last year and this year, there are several sessions that cover each of the topics I mentioned in details, and I have listed them here. So you can use this as your learning path. So thank you so much. I appreciate your time. I appreciate you all staying connected. I will stay here for questions. And if anyone would like to see a demo of the Azure Machine Learning Service, I'm happy to do that as soon as we have covered the questions.
Just a question. When you're doing the training, is there a way where you're sampling all this stuff that if you don't save it, can you not consume and be charged? I mean, is there a way to minimize the costs of while you're doing the training of the model?
Very good question. Both Azure Databricks and Azure Machine Learning Service, they can provision a compute on demand only for when you are training your model. So you don't need to have the virtual machines running all the time. So yes, you can do that. I wanted to show you here on the studio, since you asked a great question, and I was going to show everybody the Azure Machine Learning Service. So in the Azure Machine Learning Service, if it behaves well, yeah. Okay. So what is the name of the person who asked the question?
Wilson.
Wilson, thank you for the question. So in here, this is the Azure Machine Learning Service Studio. This is where you can manage your models end to end. So here's where you can register your data sets, the connections you have, the experiments you've had, because let's say today you started working doing the analysis of your data and you were going very well with a logistic regression model. But then tomorrow you're going to test a linear regression model. You want to make sure, similar to a scientific experiment, that you save the results you have had. So with Azure Machine Learning Service, you can save not only the data set, but the results you have had. You can have pipelines that combine the data processing and the model training. Then once you have trained the model, you can actually register the model. And once the model is registered, you can publish that model as a web service. You can publish that model as an endpoint that runs on a container. But to your question, Wilson, here is where you say, I want to provision this compute on Azure. Let's say this VM with GPU, etc. Then when I'm training the model, when I'm running the model, I can point to a specific VM, to a specific compute resource. Okay? But yeah, Azure, for both Azure Machine Learning Service and Azure Databricks, they have the reference for a compute or more one or more compute resources, and they can control the resources consumption and let's say auto scale the compute based on your training. Does that answer your question?
Yes, great. Thank you very much.
Sure. I am looking for an old demo that I could show you a little bit more detail. So let me just, while people are thinking about their questions. Yeah, here, Azure ML Ops. This is the environment I had provisioned for my other session. Yeah, this is cool. So in here, for this demo I did before, I had registered my data set. I had different experiments, and you can see here, I had this scenario for diabetes, my diabetes experiment, and I could see here the different runs I've had. And for each run, I can see, I can compare, for example, what are some of the metrics I wanted to look into. This is what I was mentioning in the call, like explanation, fairness, trying to add ethics into the process. And for, let's see if somebody is gonna get a gift here. Does anyone knows what SE stand for? Okay, so this stands for root mean squared error. This is one of the key metrics we use in machine learning to define the accuracy of the model. So these are the metrics we can use here to compare the different runs we've had in each experiment. So for example, if I compare the first run here, what was the RMSE? You see, this prediction here was very bad. So when I started, it was only 50% accuracy. Now, when I go to number 10, my root mean squared error, no, this was not good. So I think it was number 9. I had somewhere. But you got the idea, right? So you can compare the different metrics you have. You can view here. So this can compare the different runs, the different executions, and you can see here on the bottom. In terms of registering the model, I had registered this model here, which does the recognizes some characters, and I had exposed, I can expose these models, for example, in here, I can click deploy, and I can deploy this model as an endpoint and to Wilson's question, one thing is the compute you use to train the model, and you can use that compute resource on demand. But once you want to make your model available for predictions, you can define if you want to make that model available on Azure Kubernetes Services or Azure Container Instance. Because at the end of the day, this is just a Docker container. And I could deploy this model. The last one I wanted to show you here, this is the auto ML capability. This is just ran. Let me see if I remember. In here, this is one ran that I had, one execution I had for AutoML, and you can see here what it did in the left column. It had different machine learning model, and based on my data set, it explained here what is the model that had the best accuracy, the best prediction. And R2 is another synonym for the root mean squared error, the R2. Can anyone explain why the voting ensemble is one of the best models here? Why it has the best accuracy? Yeah, it's just because this model combines other models. So that's why it has a good accuracy in prediction. But for example, this model is very good for predicting a certain value, but it's not good for explaining how you got to that value. And if we want to understand how the model works, because we need to explain out to the outside world, perhaps this is not the best model for you to use. Perhaps you could choose a model that does not provide that great accuracy, but gives you a lot of explanation of how it got you a certain result. This is what I wanted to show to you in terms of Azure Machine Learning Service. Again, Azure Machine Learning Service end-to-end management integrates with Azure DevOps. And it actually, this is the implementation of what, let me just show you all here. Let me just paste here on the chat window. The community, Microsoft, Google, AWS, they have been investing on this idea of ML flow, which is just to have a standardized way to register models, APIs for doing lifecycle management of models. And that's documented in the ML flow initiative. So the point here is that Azure Machine Learning Service adheres to all the best practices that are recommended in the ML Flow initiative, which at the end of the day is all about tracking the execution of models, tracking where you're registering them and the accuracy you're having, and having a common API to do all of these activities regardless of which environment you're using. Thank you, everybody who watched or who is going to watch the recording.
Yeah. Maybe we can make a second part soon when you're available.
Yes.
Always happy to have you here.
Sure. Always happy to be here. Thank you so much, Cecilia, for facilitating.
Yeah, thanks to you. Thank you so much for being here.
Sure.
And okay.
Have a good day.
Have a good night, everybody.
Bye-bye.
Thank you for attending. See you soon.